Welcome to linear algebra class. We'll meet on Tuesday and Thursday at this room 32255. And my office hour is every Tuesday from 12:30 to 14 at room 32304, which is just a third floor of this building. And also you are free to make an appointment to see me anytime other than this by leave your message in the iCampus or sending me an email to this address or make a phone call to make an appointment. Okay. Linear algebra is a branch of mathematics concerning vectors and mappings. Linear algebra is central to both pure and applied mathematics. Techniques from linear algebra are also used in analytic geometry, engineering, physics, and natural sciences, and computer science, and computer animation, and the social sciences. A geometric quantity described by a magnitude and the direction is called a vector. Okay. In the first week, we will cover chapter 1. Okay. Before we start, I will show the materials that we can use. Here, this is a web content that I made for you. This web content have the address to download the textbook, and also most of lecture notes for each of chapters. For example, chapter 1, here there is all the problems and exercise problems and with the solution in it, and also the code to show to the same computations. Adding two vectors or subtract or scalar multiplication can be done, and also can be easily done with the code here. Oh. Here. Here. 네, 안 먹혀? Okay, here, yeah, so lecture note and can be found in here, and also, the movie clip of each of lectures for the sections were made uploaded in here. So, for example, chapter 4, the definition, the determinant. It can be found in here, so you wouldn't have any difficulty to double check what you have learned for the concept that will be covered before and after the class. And yeah, those informations here. PowerPoint. Yes. And yeah, there are web address that has other related informations and interactive tools to simulate the linear algebraic concept that you will learn from here. For example, finding the area of a triangle can be simulated in here. we made this. And for example, if you change the point, then area are varied like this. If you change it, then then we will find, you see, the area can be found by using the determinant of a matrix, and it's simulated in this way. For the three-dimensional things can be also done. For example, and in here, these are the area can be found like this. And these, so most of concept can be simulated in here, and we developed most of this for you. And also there's a syllabus and lectures and other related information in it. Okay, for chapter 1 here. And one thing. Yeah. Okay, anyway. Okay, yeah, before, and also our textbook is a linear algebra by myself with a couple of co-authors. And we already have a Korean version of those books, but in this course, in this semester, we will use this English version of the linear algebra. And it was the ebook, a free PDF ebook of this book was made, so you can download it from here. You can make a printout of it, and also you can download it from here, like as you see. Then you will see the book, and in this book you can not only to read this, but also you can make a copy of the code to do the computation in here like this to the things. So this is not only the ebook, but it also has the full function that you can utilize to copy or paste, and also has a tool to compute and simulate everything that you need to do it with the book. That possible. And what else? And this book was available for free to you due to the generous contribution of Hyundai Car Foundation. And this is a content that will be covered over this semester. We start from the definition of vectors and inner product and vector equations. Then we'll start the solving linear system of equations and matrix computations and determinant linear transformation. Then we will have a midterm examination at the 8th week of the semester. Then we will continue from the 9th week to cover the dimension and subspace and matrix diagonalization and general vector space. And we will conclude this semester with how to find the Jordan canonical form of the arbitrarily given matrix. Okay, our evaluation will be based on your attendance, 20%, and presentation and homework, quiz, and midterm examination for 20%, and final comprehensive examination from chapter 1 to 10 of 30%. These are the notations that we will use and in the lecture, and also some of the solutions which was already made are using some of these notations. A implies B. This notation means if A is true, then B is true. That's what it means. This notation, which is called if and only if, says if A and B are equivalent, which means A implies B and B implies A. Okay, so this means the double implication of both sides. And you know this notation, set membership. Yeah. Element A is in the set S, that's what it means. And subset, this means the set A is a subset of B, can be notated in this way. And this notation refers to therefore, so when in the logical consequences. This notation is used to say because when you offer your reasoning to explain the step of your explanation. This notation E, the flipped E, this means there exists an element X that satisfies this sentence P of X. This means there is at least one X such that P of X is true. Sentence P of X is true. That's what it means. And this flipped A is called the universal quantification. So this means for all X that satisfies P of X means P of X, sentence P of X is true for all X. That's what it means. This will save lots of time and energy when you solve or prove the theorems and the problems. Okay. Some of my earlier students solved many problems of this book already by using this, which will be posted. So yeah, you will see these notations in their proofs, which makes it much easier to understand. Okay, linear algebra class orientation. Okay, here. And also, in this website, yeah, you will find some many of the matrix power. For example, yeah, this is many of the information that you already have. Power of matrix A, like this. This is a matrix, then eigenvalues of matrix A can be found in here, like this. And the eigenvalue and eigenvectors can be written in this way. And matrix diagonalization can be done in here, something like this. So the 10th power of the matrix A can be computed in this way, like this. Okay, anyway. So anyway, this website will be a pretty good resources for you to save times to type and memorize the code that you may need to use it. Okay, this web address. And for example, here, for example, if you can copy this, then you will use, you can copy those codes from the textbook or thing. Then you can do the computation by just cut and paste of this from the textbook. And you can copy. You can copy the code. Then you can put it in here to do the computation. So it will be really good resources for you to use. And I'll explain this later. And I also made the ID and password to do this and it will be noticed once again later when it is needed. Here, now we start to explain the syllabus before we cover the section 1.1 and 2, which is a review of what you already know before we start the linear algebra class. Any question before we go through the syllabus? Here. Okay. First, okay, syllabus. I just added this this site, this web address, which this is a Google Translator. So in this course, there are international, several international students here. So when you when you need to understand some Korean terminology, then you can use this web address to understand it. If you find any difficulty, just feel free to ask me. Then I will be very happy to. Okay. Where are syllabus? Where is our syllabus? Syllabus. Okay. I see we had to go back nearby. Okay. Yeah, this is linear algebra class. Code number is this, and this is yeah, basic science and math course, and yeah, you can find the information from this web address on me, and I recommend you have some knowledge of calculus 1. But it's not a requirement. But in the earlier part of this class, yeah, there will be no, it will be all new, so it won't be needed. But at the end, then chapter 8, 9, in there, then we need the knowledge of differentiations to find the what? Orthonormal vectors and general complex matrix and general complex vector space and Fourier coefficient. And those, yeah, you will need, we will need some knowledge on the calculus 1. So, yeah, I recommend you to get prepared for that. Okay, we will meet on Tuesday and Thursday in this room, 32255, and I have office hours. And yeah, I told you the textbook can be downloaded from this web address. So yeah, you can see, and you can make copies, and you can make links, and it's all available there. Particularly, yeah, in this semester, I offer 2 linear algebra classes on Tuesday and Thursday. Tuesday and Thursday, not Monday. This first session 41 is designed as the course which is all the lectures are recorded. So all the lectures will be given 100% in English, and also the lectures will be saved. So I recommend the international students to take this course to have full privilege of it. The session 42 was designated at the university ACE project course, which is a student-oriented lecture. So this course we will have more discussions, and projects will be given, and teamwork, like what? Team project will be given on here. So, but you are in here, so I recommend And also you know all the lectures will be given in English and will be recorded. And most of the linear algebra class at Songyungwan University was designed as a flipped and PBL action learning class. So the introduction was given in here. And as you see, all the lectures were already saved in here. So you can like this. For example, section 1.3 here. This is a lecture of section 1.3, which was saved last year. So you lectures. So yeah, you can take a look on lectures before you come to class to understand what will be taught. Okay, so you can make questions before you come to class, so you can solve, you can get answers on most of your questions during the class hours. So that's the concept of flipped learning that Songyungwan University have tried to build up. Okay, and also, yeah, you will find the solutions and problems in this web address from chapter 1 to chapter 10, in addition to the lectures. So, and also other related the content, including the sample midterm examination and sample final examination with the solutions, etc. Okay. Okay. So yeah, you have a full content even before the the class start. So you are very lucky to be in the very well prepared learning environment over any other schools exist. Next, this is a content I have developed for you. I called it the lab manual. This covers all the contents from chapter 1 to chapter 10. These are the things that you have to know and you have to be able to manage it at the end of this semester. You should be able to add and subtract and find the scalar multiplication of vectors and find the norm and size of a given vectors and find the inner product and find the projection to find the shortest distance between a point and a plane, and solving the linear system of equations, finding the low reduced echelon form, and do the Gauss-Jordan elimination, and matrix computation, and finding the inverse matrix, and finding the finding the determinant. If you, and finding the adjoint matrix and the inverse matrix, finding the characteristic polynomial of a given matrix, and finding the eigenvalues and eigenvectors, and linear transformations, image of the linear transformation of a given vector, and finding the corners, and even we can do the simulation and animation and computer graphics with the data and point by multiplying the matrices at once. So actually this shows the given triangle has been rotated and the flipped or enlarged and things. All those kind of computer graphic can be done as an application of linear transformation. We also did write first character of SKKU, S, and we expanded it as a twice, and we shared, we squeezed, we slipped the S, and we rotated the S, and this image shows S has been expanded and squeezed and rotated, and at all once. Find the dimension and find the length, and Gram-Schmidt also normalization process. Actually, this is a goal of this course. At the end, you should be able to find the matrix diagonalization of a given matrix when it is possible. This Gram-Schmidt also normalization process is the concept that you need to do so in. So in chapter 8, you will learn the matrix diagonalization, which is the main concept that you're supposed to know to pass this course. The earlier knowledge that you're going to learn will be all used to deal with this matrix diagonalization. That will make you very easy to do all the computations with the much simpler form, like finding the tenth or hundredth power of a matrix, which can be used to expect what will be happened after 50 or 100 years after, something like that. And the last chapter is a Jordan canonical form, which works for general matrix, even for the matrix which is not diagonalizable. And singular value decomposition is the one of the most important concepts which is used in the real world problems here. And all those things will be covered. And the general concept of inverse matrix will be found by using the singular value decomposition, which will be covered in chapter 7. And general vector space. And here we will generalize our concept of the R2 and R3 and Rn to complex vector spaces. And the inner product will be generalized. Euclidean inner product concept will be generalized in a general setting of inner product space. And particularly here in Wronskian, which is a very useful tool. In order to deal with this, you need knowledge of the differentiation, etc. And these things can be found in here. So this actually in here, you will see what we're going to learn. And in this course, we will learn how those tools work, what's the mathematical knowledge behind it. So you can make changes to deal with the problems that you're going to meet after this class. This part explains how this course will be learned. Okay. This is just selected SKKU scripted PBL class. That's why all the lectures are saved, so you can go back before and after the class. And we will cover the concept from chapter 1 to 10 that include the linear system vacation and vector space, subspace, basis, linear independence, eigenvalues and eigenvectors, and matrix diagonalization, linear transformation, and determinant, and the general vector spaces. You will have online lectures before the class, and you will make questions and answers in Q&A of iCampus. Then we will clear up all of your questions in our class. And the goal of our class is we will discuss many interesting problems from textbook and the web, and all should understand most of linear algebra concept and do small and large size computation of the above concept, and should be able to explain what you know and what you did and what you found from the problems and the concept. Okay, and this shows the weekly contents that will be covered, and also this will be a good resources for you. This web page has the most of the problems and solutions in detail, like this, from chapter 1 to chapter 10. So, yeah, whenever you have a difficulty to understand the process of solving the problems, then yeah, you can refer it. So here, for example, how to find the also normal vectors from a given complex vectors like this. Then this shows how to do it, and also this has the same code in here, so that you can do the computation in here. And English lectures and the books. Here, the important evaluation. Evaluation, like I said you before, participation and presentation will be counted as a 20%. Homework, quiz, and PBL report will be counted as 30%, and midterm 20%, and final comprehensive examination as 30%. The exam evaluation will be based on your performance on each of these categories. And yeah, you know the honor code of Oxford University. And if you need help, you can get it from me with my office hour and by appointment. And also, you can get help from TA and the Student Support Center with these phone numbers and address. And in these web addresses, you will find the most of the content of our textbook. So yeah, we may use some of this as our lecture note. Okay, finding the argument matrices like this, that can be done in here. If you change different matrix, then it can be done with the same code only. So this is a lecture note, actually based on our textbook here. And from chapter 1 to 10. And yeah, I told you the cyber lab and simulation tools here. And the lectures were recorded, so you can always use this. And I have added some references. I think that will be enough information for you to understand what we will do and what you will learn and how. Any questions? Here, I have shared some of the informations that may help you to understand the 21st century mathematics and the technologies. Actually, I have recorded all of my lectures of last semester on the story of mathematics, history of mathematics, and it has a lot of story that you may like it, you may enjoy it. But also here, this is a high school calculus. For example, you must have learned how to find the domain of a function or range of the functions. And all this can be done in this. Find the domain and range of this function. Here, domain and range. Here is the domain of this function and range of this function. It also shows it as a graph like this. Okay. and trigonometric function, and solve the linear system of equation. Solve the inequalities like this. Then it shows the axis which is bigger than -1 and less than 3 satisfies these inequalities. And also this can be done in here. Solve this, and this goes, gives us solutions like this. For example, here, integration, application of integration, finding the integral of this function that you must have learned before. And this can be done. Integral of this function is this. And this can be found in here. And also this can be done in here. Integrate x cosine x square with respect to x, and from x is equal 0 to square root of pi. Okay. No, this one. Here. Here. Integrate the x cosine x square, and answer is 0. And it also shows you have found the area of this function from here to here, like this. So nowadays here you can find the area between these two functions. You can draw the pictures and you can do the computations like this. Yeah. Integrate this function from here to here. And this also shows area between these two functions, between these, something like this. So what you have learned over the last 12 years can be easily done already. So now the computation is nothing but the simple things to do. What you need now is to understand the mathematics behind this. The conceptual mathematics of modern mathematics starts from the introductory linear algebra class that you will cover in this course. And also the calculus here, I think you can do more. In calculus class, you are learning a single variable calculus in the first semester and multivariate calculus in the second semester. And single variable calculus, for example, if you can draw the graph of quadratic function, then you know the solution already in here, by just draw the graph of it. If you draw the different graph, then you have a different equation and a different graph and different solutions. Okay, you have a solution here and there. And cubic functions. So, for example, if you have a polynomial, if you can draw the graph of it, then that means you have the solutions already. And power functions from n for general n, and for the trigonometric functions, if you have a tangent here, instead of arc and secant, then you have a graph of the tangent graphs and exponential functions. And so here, and if you do the multivariate calculus, if you find the what? Double integrals. If you do the double integral of this function with this inverse, then you have a solution which is 49/12, which can be found in here. If you change the functions here, then you can do the same thing. So mathematical concept and the logics behind this is the things that you should understand from the college mathematics. Okay. And the triple integral, then line integrals, and all these things. These are the main theorem for this chapter, this section. And line integral of these functions over the upper half of the unit circle, then it can be graphed in this. You are doing integration of this on this interval, this domain, then you have the solution which is pi, which was already given, something like this. So yeah, these are the calculus. Yeah, there are papers that you can refer in. And introductory linear algebra class, this is what you're going to learn this semester. Is there anyone who took engineering mathematics before? Engineering maths. Any student who took an engineering maths before? No? Engineering maths. Okay. Anyone else? I expect there are some junior students here who supposed to, from the engineering school, supposed to took it. So here, in the engineering mathematics, yeah, you must have covered the linear algebra and differential equations and Laplace transformations and the complex variables and Fourier analysis and the conformal mappings, etc. For example, for the second order differential equations, here, yeah, this is what you have learned and how to solve this differential equation, which means equation that involves the derivatives. And the solution can be found in here, but also can be found in here, like this. If you have a different problem, all you have to do is just change the function. Then the same code will work to give you the solutions. This for the partial derivative, partial differential equations, also the same thing can be done. The solution for this can be also found in here, which is exactly the same as what you have found by hand. Okay. Anyway, and for the statistics, this is a Python language, and this is R, and the earlier ones are Python and Mathematica. Okay, here, if you want to generate the randomly the coin tossing, and you can, if you choose the randomly the 6 number from 1 to 45, or 40 numbers from 1 to 435, something like that. So all can be done. You can choose. You can check the probability, and you can do what? You can check the probability, or you can find the what? Simple what? You can do standard. You can find the variance or standard deviations from the given data, or you can even call the data. And these are so you are living the world that all kind of this technology are available. Yeah, you should be aware of those. And so, now you have to start to learn how can use those. In order to do so, you should understand the main concept of mathematics properly. Okay, here, and also this will be a good resources for you. Here, this is the second course of linear algebra. Now, our linear algebra class is the first course, and in here, for example, at the determinant here, if you see, it has this is second course, so more diversity of the problems and complex, interesting, more problems are in here with the full details of solutions like this. So when you study the linear algebra, if you want more interesting and hard problems, and if you face the difficulty of solving those problems, then this will be a good resource. It has almost all problems and solutions of the second course from all chapters. And matrix analysis and numerical linear algebra, and these are the basic background for mathematical modeling and study on the big data or data sciences. So these are all started from linear algebra. So yeah, you can use it, and here big data. In here, yeah, this is the lecture that I gave last semester, and this you will see how the mathematics and linear algebra concepts are used in the data science here. And anyway, I think that's the kind of introduction of this semester with the related resources. Okay. Any questions for the course information? Then I will close this lecture with the review of the concept in section 1.1 and 1.2. Yeah, you know the definition of vector, maybe, which is an object that has an initial point and terminal point. Okay. And you know how to add these two vectors. And the definition of the vectors in R2, and how to compute with these. And vector addition and scalar multiplication for the vectors in R2. And now, then we expand, we generalize this concept to the vectors in R3. And we define the concept of equivalence, which means that if two vectors is called the same, or equivalent or equal, if the size of two vectors are same and each component are equal. Yeah, we can do the matrix, the vector addition and scalar multiplication. And we define a zero vector and negative vector of a given one. And we expand, we generalize the concept in the n-dimensional vectors, the same thing. And each entry is called a component of a given vector. And two vectors are equivalent or equal if the size of two vectors are same and each entries are same. Vector addition and scalar multiplication is similarly defined, and like what you already knows. And the property of the vectors is generalized for the vectors in Rn, but properties are all same, like as what you have learned in high school years. And property of zero vectors. And this is, I think this is the first concept that you should know. Linear combination of a given k vectors. This is the, for a given k vectors, if we multiply a scalar on each and add all them, then it forms on another vector x. This vector x is called the linear combination of these given k vectors, VIs. Linear combination. This is the concept that we'll use it over and over again in this course. Okay, so we should be able to find how to compute it. And the size of a matrix, size of a vector, this is called the norm. We will use a terminology of norm instead of length or magnitude for a given one. And the difference of two vectors, the distance of two vectors. And inner product. This is a special case of the inner product in Rn, which is called the Euclidean inner product. In engineering mathematics, it's called the dot product. But this is a special case of an inner product which will be covered in chapter 9 in general vector space. Okay, the properties of it. And this is the Cauchy-Schwarz inequality that you know as well. And then the angle is defined. Okay, is there anyone who can define angle properly? Defined as this value theta that satisfies this, which comes from the Cauchy-Schwarz inequality. This concept is not only for the vectors in R2 and R3 in Rn, but also work for any vectors such as matrices and continuous functions and differential functions, etc. So yeah, the angle is defined in this way, and this general concept will be used over and over again. Gram-Schmidt diagonalization process and matrix diagonalization process, all these are related with these angles. Okay, and okay, so unit vector is defined, and yeah, triangle inequalities, and also this is the last concept in chapter section 1.2. Here, every vectors in R3, which can be written as x1, x2, x3 in R3, can be represented as a linear combination of these three unit vectors, 1, 0, 0, 0, 1, 0, and 0, 0, 1. The linear combination of these form this. So every general vector, arbitrary vector in R3 can be represented as a linear combination of these three unit vectors. So when you study the general vectors in R3, all you need is to know is the nature of these unit vectors. So if you understand these structures, then what you have to study is a very small compared to the infinite many objects that you will face. So I think that's the end of section 1.1 and 2, and we will start from section 1.1 from next Tuesday. Any questions? Okay, the class dismissed. We'll see you next Tuesday. Yeah.